we have done lots of inverse trig in 7.1. So 7.2 is just a natural extension of 7.1. The difference here is we're going to be composing two different trig functions. So for instance, if you look at number 1, instead of doing a sine with an inverse sine, we're going to do a tan with an inverse sine. Or number 2, a secant with an inverse tan. But the idea is the same. So I'm going to draw out circles for each of these, and you can kind of choose whether you want to do that or not. So let's do the inside part first. Inverse sine of negative a half. Okay, so you do have to remember, inverse sine can only be between negative pi over 2 and pi over 2. So when I do negative a half, I can only be looking at the fourth quadrant here. So my theta is in here. I have negative 1 over 2. So obviously this guy's going to be a 30, 60, 90. With the 30, or the pi over 6 as the reference angle. Okay, now we do have to remember that if we're going clockwise around the circle, the answer to this is going to be a negative pi over 6. Okay, so then once we determine the inside brackets, if I rewrite the problem then, I could write tan of negative pi over 6. And I've already got the triangle drawn here, so I don't have to do a new triangle or anything. So tan of negative pi over 6 would be negative 1 over root 3. And we always have to simplify these. So negative root 3 over 3. So now let's look at number 2. So again, the inside first. Inverse tan of root 3. Okay, so tan can be in the first or fourth quadrant. So once again, it's a positive tangent, so it's going to be here. Opposite, adjacent, hypotenuse. So another 30, 60, 90. So the one across from the 60, this reference angle, that's going to be 60 degrees, pi over 3. We're going to answer it in radians. So if I rewrite the question again, it would now be secant of pi over 3. Alright, so we've got our triangle here. We don't have to redraw it. Secant pi over 3 would be hypotenuse over adjacent. So for this question, it would be 2. Number 3. Cosecant of the inverse cosine of negative root 3 over 2. Okay, remember, negative cosine. If it's negative, for this one, it's got to be in the second quadrant. Alright, so here's my triangle. Once again, a 30, 60, 90. And the angle I'm looking at in here would be the 30. So this one's kind of tricky because the 30 means pi over 6. But if I'm in the second quadrant, I can't just call it pi over 6. I have to call it 5 pi over 6. In other words, it's 1/6 of a pi short of being all the way to pi. Okay, so there's the first part. Now I'm going to find the cosecant of 5 pi over 6. So again, I've got the triangle all laid out. Cosecant would be hypotenuse over opposite. It would be 2. The next 3 examples are a little bit different, and here's why. These 3 examples have the inverse part of the function on the outside, so we might have to do a bit more thinking on these. So let's take a look at number 4. Cosine of negative pi over 3. Okay, you need to keep in mind, negative pi over 3 is not part of the range for inverse cosine, so I can't give an answer of negative pi over 3. So let's draw it out. You might get the idea before we even finish, but negative pi over 3 would be here. 60 degrees, which means, here's my triangle in here. So if I answer the inside part, this part right here, it would be 1/2. Okay, so then I'm going to rewrite the question. Inverse cosine, now of a half. Okay, here's the tricky part. We know that inverse cosine can only be in quadrants 1 and 2. So out of those 2 quadrants, where is inverse cosine going to be positive 1/2? Well, it's going to be in quadrant 1. Okay, which means it's this 60-degree angle, or the answer would be pi over 3 in radians. So for that one, we did have to switch quadrants. It's a little bit different than what we've done. Let's do another one. Tan 2 pi over 3. Okay, once again, 2 pi over 3 is not part of the inverse tangent range, so I can't answer 2 pi over 3. So if this is my pi over 3 reference angle in here, 60 degrees, that means it looks like this. Okay, So if I just answer this part, what is tangent of 2 pi over 3? We should say it's negative root 3. Okay, so again, let's rewrite the problem. Inverse tan of negative root 3 now that I've rewritten it. Okay, so now we go back to the idea that inverse tan can only be in quadrants 1 or 4. Since this one's a negative root 3, it's going to be in 4. So opposite, adjacent. Okay. All right, so again, it's got to be the same reference angle, only this time we have to call it negative pi over 3 because it's going the other way around the circle. Okay, let's do one more of those. So if I look at number 6, inverse cosine of the sine of 7 pi over 6. We always want to do the 7 pi over 6 part first, the inside part first. All right, so let's figure out where is 7 pi over 6. All right, it's 1 1/6 of a pi, so it's going to be here with a pi over 6 reference angle, which is 30 degrees. So it's got to look like this. Both of these negative. So if I just look at the inside part, sine of 7 pi over 6 would be negative a half. Okay, but inverse sine cannot be in the third quadrant. Inverse sine can only be first or fourth. So where is it going to be negative a half like this problem is asking? It's got to be in the fourth. Okay, so my answer, if I rewrote it from the beginning, inverse cosine of negative a half. Okay. Oh, excuse me, we switched, didn't we? Go back here a second. If the cosine is negative a half, that means the adjacent is negative 1. There we go. Okay, so cosine's negative a half, so that means this angle in here. Okay, hold off on that one. I actually misread the question. I thought it was saying inverse sine. It's inverse cosine the whole time, so I'm putting it in the wrong quadrant. So hold off on number 6. Sorry about that. We'll go over that in class tomorrow. Alright, the last little bit of this video is just how to use your calculator to help you. Because what I want you to keep in mind is, number 7 for instance, cosecant is actually 1 over sine. It's not like just doing inverse sine in the calculator. Alright, and the way we enter these is very specific. We have to think about the idea that if cosecant is 5, sine must have been 1 over 5. Okay, so in my calculator, that's what I would enter. Okay, so I'll let you guys go ahead and do that. But what I want to make very clear is it's not the same as 1 over sine 5. Very different values. Okay, so this is the one I want you to enter in your calculator. Okay, take a look at number 8, same idea. If secant is negative 3, that means cosine must have been negative 1 over 3. So I want you to enter the inverse cosine, second cosine on the calculator of negative 1 over 3. And if cotan for number 9 is negative a half, it means tan must have been negative 2. So you're going to enter inverse tan of negative 2 on the calculator. And these are all approximations, so just take those out to 2 decimal places.